Chapter 2, Section 4, Classification of Matter. So we're going to look at a flowchart real quick. Here we go. How can we distinguish between all the different kinds of matter? Well, first off, can it be physically separated? We're going to talk about what that means here in a moment. But for right now, just follow the flowchart. If you can physically separate the matter, it's a mixture. If you can't, it's a pure substance. Can the pure substance be chemically decomposed? If the answer is yes, it's a compound. If the answer is no, it's an element. And that makes sense, because if you're an element, you can't be decomposed anymore, because you are already that element. Versus a compound, which is made of two or more types of atoms, you can chemically break those apart to get just the individual elements. In matter, over here for the mixtures, again, what's it mean to be physically separated? Well, first let's talk about these mixtures. We have a homogeneous mixture, which means they all look the same. Heterogeneous means they look different. That's what it means by, is the composition uniform? Yes, they all look the same. Homogeneous, aka a solution. No, they look different. Heterogeneous. Well, physically separating means something like this. Let's say you have a bunch of iron in a bunch of sand, and you mix them all together. How do I get the iron completely out of the sand? Well, I could individually pick up every little piece, but that would take a very long time, and I may not get every single piece by my hand. But what I could do is, I could use a magnet. A magnet, because iron is magnetic, there we go, magnetic, I can use a magnet to pick up all the different pieces of the iron, and that leaves just the sand. Or something like salt water. How can I get the salt out of salt water? Easy. You just boil it. Because salt and water have two different boiling temperatures. They have a property, which is boiling point, and they have different boiling temperatures. Salt has a very, very, very high boiling point. Water boils at 100 degrees Celsius. So if you turned on a stove that had a bunch of salt water in it, and the water got to 100 degrees, it would boil off all the water. All the liquid water would turn into steam, and all that would be left is the salt. A misconception a lot of people have is that the salt boils off and turns into steam with the salt water, or with the water. That does not happen. Again, when you boil water, liquid water will turn to steam, and what's left over is all the salt. So that's how you can physically separate them. The same is true for that brass coin we saw in a previous video. How do I turn that brass coin, which is a homogeneous solution, it's a solid homogeneous solution, how do I get just the copper? How do I get just the zinc? How do I get just the lead? Well, lead, zinc, and copper have different boiling points. So again, you would heat up that coin, and when it gets to a certain temperature, let's say the copper would burn off, and then you're left with just the zinc and the lead. Well, you keep heating that up, and then eventually the lead will burn off. Not necessarily in that order, but I'm just giving you guys an example. It's also how they refine gold. Because when they find, or even any metal, iron, tin, when they dig up all these metals in the caves and the ground and earth, they have to refine them. What they do is they raise up the temperature to burn off, to get rid of all the other elements, to get just that one element they want. That is a physical separation. Boiling and melting, believe it or not, that's a physical change. Now, why do we even study pure substances? What's the point? Well, first off, we want to understand how to utilize a substance's properties. Because when we do that, we're able to design new materials. We can make changes in everyday life. Things have changed drastically. If you look at the course of 100 years, look at what we used to have as humans 100 years ago versus the materials we have now. It is crazy. And the reason why we have so many new things now is because we studied. We understood different properties of different elements, different compounds, and we just utilized that to make new things. So we can logically deal with our environment. When we originally were trying to kill different insects and pests in cornfields and such back in the day, get rid of mosquitoes, we sprayed these chemicals that have something called DEET in it. Well, that DEET, unfortunately, was making the bald eagle eggs shells really soft. And when the mama bird sat on her nest of eggs, she squished them. And we almost lost every single bald eagle. It was on the endangered species list. Maybe still is. I know it's made a huge comeback, but we learned that the substance was actually very, very, very dangerous to our environment. And so we learned to make something different that had the same effect but wouldn't harm the bald eagles. And third is simply curiosity. It is human nature to be curious about things. So we want to study what causes things to do the things they do. Structure of matter explains chemical and physical properties. Okay, so by understanding the structure of matter, we can actually understand the properties. Why does water behave the way it does? Why does water act like a good insulator for heat, but it's also a very good conductor for electricity? Why? Well, it has to deal with the structure of it. Why is ethanol, which is this one right here, why is that explosive? Why does that catch on fire very, very, very quickly? Okay? By understanding the structure and by understanding how to change the structure, we can, as humans, create all sorts of new and crazy and exciting things. And that's just what science is.